Assalamualaikum, very good day. Today we're going to discuss a few questions involving sketching of the graph of trigonometric functions. So let's have a look at this example. It's from June 2013, paper 2.2, question number 10a. The function f is defined for from 0 until 360 degrees, okay, by f of x equals to 1 plus 3 cos x. And if we rearrange this equation, it becomes fx equals to 3 cos x plus 1. So we need to sketch this graph. We can see easily that the amplitude A is just equals to 3. The period is just equals to 2 pi over 1, because this is A cos nx plus c. So our n is equals to 1. And shift c equals to 1 means that shift 1 unit up, okay? So when the period is just equals to 2 pi, means that we have one graph of cos cycle in every 2 pi. Okay, so basically 2 pi is just equals to 360 degrees. Okay, so we have one cycle in every 360 degrees. And the amplitude is 3. So which means that if you look at this graph, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Amplitude is 3. So start off from there. And negative 3, 0, and 3. Okay, so the graph should look something like that. Okay, so this is 3 cos x. Next, we need to shift 1 unit upwards. So means that 3 becomes 4, 0 becomes 1, negative 3 becomes negative 2, 0 becomes 1, 3 becomes 4. So our new graph looks something like this. Okay, so we erase the old graph. So done with question number 1. Okay, now we go to question number 2. State the number of solution. State the number of solution of the equation 1 plus 3 cos x equals to 2. So for number 2, we need to state number of solution when 4 1 plus 3 cos x equals to 2. Okay, we know that fx equals to 1 plus 3 cos x. Then we have 2 equals to 1 plus 3 cos x. When fx is equals to 2, we will have this line here. Fx is equals to 2. Okay. So basically, this is when f of x equals to 2. And this is when fx equals to 3 cos x plus 1. Okay. So the number of solution happens when both graph intercepts. So the first graph and the second graph, which is just fx equals to 2, intercepts at 2 points, 1 and 2. Okay. Therefore, the number of solution for this is equals to 2. Okay, so that is your answer. Or maybe I should write it something like this. Number of solution is equals to 2. Okay. Okay, let's have a look at one more example. The function f is defined for 0 until 360 by fx equals to 4 cos x minus 3. So we have f of x equals to 4 cos x minus 3. Sketch the graph of y equals to fx on the axis below. So basically this question just wants us to sketch the graph. So start off from inside. Start off with 4 cos x. And we know the amplitude is equals to 4. And then period. It's just 2 pi over n, which is 2 pi over 1, which is just 2 pi, means that one cycle in every 2 pi. And we have minus 3, which is just a shift downwards, means that we need to shift 3 units downward. Okay, let's draw. If you look at the scale, we have 1, 2, 3, 4, and then this is -1, -2, -3, -4, -5, -6, -7, -8. And we know that 2 pi is just equals to 360 degrees. Just in case if you forget how to convert 2 pi to degrees, it's just 2 pi equals to 2 pi times with 180 degrees divided by pi. So you should get 360 degrees. Okay. So our amplitude is 4. We start off with 4 cos x first. So 4 that should be it. And sketch the graph. Okay, that looks quite okay. And next we need to shift 3 units down, means that from 4 becomes 1, 2, 3. Okay. From 0 becomes -3. From -4 becomes -7. From 0 becomes -3. And from 4 becomes 1. So this is just the graph of 4 cos x minus 3. Okay, done. Now let's have a look at the next example. On the axis below, sketch the curve y equals to 3 cos 2x minus 1 for x from 0 until 180 degrees. Okay. So we have y equals to 3 cos 2x minus 1. We can see that our amplitude A is just equals to 3, and our period equals to 2 pi over 2. Okay, because this is y equals to A cos nx plus c. So 2 pi over 2 is just equals to pi, which means that one cycle in every pi. And we know that pi is just equals to 180 degrees. And the value of c is equals to -1, means that we need to shift 1 unit down. Okay. So start off by plotting 3 cos 2x there. Okay. So the amplitude, we have one cycle in every 180 degrees, which means that if you look at the range of x given is 180 degrees, we only have one cycle in this case. So amplitude is 3. Means that -3, 0, and 3. Okay. All right. Next, we need to shift 1 unit down. So from 3 becomes 2, from 0 becomes -1, from 3 becomes -4, from 0 becomes -1, from 3 becomes 2. So our new graph should look something like that. Now you can erase the old graph. Okay. Okay, that's it. This is y equals to 3 cos 2x minus 1. Okay, now let's move to the next example. June 2013, paper 1-1, question number 1. Okay, on the axis below, sketch for 0 until 2 pi, the graph of, number 1, y equals to cos x minus 1. So we need to sketch this. And we know that this is just equals to y a cos nx plus c. So we have our a equals to 1, our period is equals to 2 pi over 1, which is just equals to 2 pi, means that we have one cycle in every 2 pi. Okay, one cycle. And the value of c is equals to -1. So it means that we need to shift 1 unit down. Okay. So let's draw that. Since the amplitude is 1, so we will have that as 1 and one cycle in every 2 pi. So this is for y equals, this is for cos x. Next, we need to shift -1, shift 1 unit downwards, means that from 1 becomes 0, from 0 becomes -1, from -1 becomes -2, from 0 becomes -1, from 1 becomes 0. So the new graph will look something like that. Okay. We can erase the old graph. And since we are going to sketch two graphs in the same axis, the same picture, so I will let the first graph known as y1. Okay, so maybe I will just label that first graph as y1. Okay. Now we move to the second graph. Okay, let me use the different color. Okay, number 2. We have y equals to sine 2x. Our a is equals to 1. And our period is equals to 2 pi over 2, which is just equals to pi, means that we will have one cycle for sine in every pi. So for each and every pi, we will have one cycle of sine. And there is no shift. C equals to 0 means that no shift. So let's draw that. Amplitude 1, cycle in every pi. So for every pi, there will be one sine cycle. So one cycle in every pi. So the first pi, and one more cycle on the next pi. Right? So done with the second sketching, and I name this as y2 equals to the second graph, just a small 2 down here, just to denote that we do not have the same y, different function, different equation. So y2 equals to sine 2x. Right? Okay. Now we are going to answer the third question, which is state the number of solutions of this equation here. So we want to find the number of solution for cos x minus sine 2x equals to 1. Okay, if you notice, we can rearrange this. One we bring to the left hand side, and negative sine 2x we bring to the right hand side. We will get cos x minus 1 equals to sine 2x. Because when you go across equality symbol there, the symbol change from 1 to negative 1, from negative sine 2x becomes positive sine 2x. So if you notice that cos x minus 1 is just equals to y1, right? And then sine 2x is just equals to y2. So what is the number of solution when y1 equals to y2? Means that in this graph, where do we have both graph y1 and y2 intercepts? Okay, y1 equals to y2 happens at the first point here, a second point here, and the third point here. Okay, so the answer for this question is just equals to 3. There are 3 points where y1 equals to y2. So the number of solution when y1 equals to y2 is just equals to 3. Now let's have a look at this example, June 2015, paper 1-1, question number 1. We have for A, y equals to sine 2x, right? So A is equals to 1, period, is equals to 2 pi over 2, which is just pi, which is just 180 degrees. Means that one cycle in every 180 degrees. And our C is equals to 0, so it means no shift. Now we are going to draw our sine graph. Okay, let's see. So the amplitude is 1. There will be one cycle in every 180 degrees. So in this range of 180 degrees, there will be only one cycle. So we will have amplitude 1. It shouldn't be sharp. It shouldn't be sharp. It should be curvy. So do it slowly. Okay, that looks fine. Done with A. Now we move to B. So for B, we have y equals to 2 cos 3x plus with 1. So A is equals to 2, period, is equals to 2 pi over 3, or 2 times 180 degrees over 3 should get 120 degrees, which means that one cycle in every 120 degrees. And we have C equals to 1, shift 1 unit up. Okay, so let's see. We do do not have any problem with the amplitude because basically the amplitude is just 2, but we have problem with the period. So one cycle in every 120. If you look at the scale, there is 180. You don't know where to put your scale, but somehow 120 can be divided into section of 30 degrees, 30 degrees, 30 degrees. Means that you have 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, and 180 degrees. So within the scale, within the range for x 90 degrees, there should be divided into 3 sections. Let me see, how can I do that? Something like that. You divide 90 into 3 main sections. So basically this will equals to 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, and 180 degrees. Okay, so there will be one cycle in every 120 degrees. So for every 120 degrees, there will be one cycle. The amplitude is 2. So becomes something like that. But then again, we need to shift 1 unit up, means that from 2 becomes 3, from -2 becomes -1, from 0 becomes, from 0 becomes 1, from 0 becomes 1, from 2 becomes 3, 0 becomes 1, -2 becomes -1. So we are going to draw our new graph. Oops, sorry. So you need to do it carefully. Probably. Okay. There you go. So erase the previous graph. Okay. There you have it. We have 2 graphs. So y1 is equals to sine 2x, and then we have y2 is equals to 1 plus 2 cos 3x. Okay, next question number 3. Okay, for the last part, state the number of solution of sine 2x minus 2 cos 3x equals to 1. So basically this is just if I move that to the right hand side, we'll get sine 2x equals to 1 plus 2 cos 3x. Okay, so which is just y1 equals to y2, if you notice. So state the number of solution when y1 equals to y2. So which means that at how many times does both graphs intersect? We have one here and one here and another one here. So the number of solutions should be 3. Okay, now let's have a look at the next example. The diagram shows the graph of y equals to a cos bx plus c for 0 until 360 degrees. And where a, b, c are positive integers. So we need to find the value of a, b, and c. So we start off with a. If you look at this graph, basically if you divide this graph into two sections, you will have from top to bottom 7 minus 1. So you should get 6 units. Okay, 6 units means that from top to middle and from middle to bottom there will be 3 units, down 3 units, up here. So which means that the value of a is just equals to 3. Okay, because you know when we draw a cosine graph, we always start 3 is the height from the middle. So a is the height from the middle. So in this case, the height is 3 units, middle up, middle down. Okay, so done with value of a. Now let's have a look at b. One cycle of this cosine graph lies in 180 degrees, if you notice. So means that period is equals to 180 degrees or pi. And we know that the formula for period is 2 pi over n. In this case, our n is b. So therefore, 2 pi over b is just equals to, the period is pi. Means that b is equals to 2 pi divided by pi equals to 2. So that is the value of b. How about c? Okay, c is the shift. Okay, if you notice, since the amplitude is 3, then the original graph should look like this, 3 and negative 3. But top here, if smooth, from 3 to 1, 4, 5, 6, 7. So 4, 5, 6, 7. So it moves 1 step, 2 steps, 3 steps, 4 steps. Means that shift upwards from 3 to 7. Shift upwards, how many units? C equals to 4. Right. Similar to bottom, negative 3, negative 2, negative 1, 0, 1. So it becomes from 3, negative 3 to 1. So it's obvious that C is equals to 4. Okay, now let's move to the next example. The diagram shows the graph of y equals to a sin bx plus c for 0 until 2 pi, where a, b, and c are positive integers. Right. First, start with the value of a. A obviously from top to bottom, from middle to top. Okay, this is your a. This is your a. So the difference is how many units? If you look, 4 minus 1, so this should be 3 units. So A is just equals to 3. How about the period? Period, if you can see one cycle, there is one cycle in every pi. So means that period equals to 2 pi over b. In this case, our n is b. And given that one period is just equals to pi, to 2 pi over b, therefore b is just 2 pi over pi, which is just 2. Okay, so we have the value of b. Done. How about c? It's so obvious that c is just positive 1. We shift the graph up 1 unit. Okay, now let's have a look at the last example. The diagram shows the graph of y equals to a plus c tan b x passing through the points 0, 3 and pi over 3. So we want to find for y equals to c tan bx plus a, and it is easily see that the normal tan graph without the shift will start from 0, but the thing is now it starts from 3. Okay, because here from this coordinate we know that the value of y there is 3, so which means that we have a shift of 3, 0 to 3. Okay, now let's have a look at the period. So one cycle for tan graph looks like that. Okay, so in this cycle it shows that the period for this graph is pi over 2. Okay, one period is pi over 2, and we know that for tan graph period is just pi over n. In this case, pi over b is just equals to pi over 2. Therefore b is just equals to pi times with 2 over pi. So b is just equals to 2. Okay, so you should get 2 for the answer for question number 1. Okay, let me resize that. So the answer is a equals to 3 and b is equals to 2. That is answer for number 1. Okay, let's have a look at number 2. Given that pi over 8, 7 also lies on the graph y equals to c tan, since our b is 2, and 2x plus with 3. And we know this is the value of x, this is the value of y. Substitute inside. 7 equals to c tan 2 times pi over 8 plus 3. Okay, so 7 equals to c tan, simplify that, becomes tan pi over 4 plus 3. If you press your calculator, make sure that your mode of your calculator is in radian. So if you have tan pi over 4 we should get 1. So 7 equals to C times with 1 plus 3. Therefore, C is just equals to 4. Okay. So that is the last example. I hope that you understand on how to answer questions involving sketching of the graph of trigonometric functions. The next class we will focus, in the next video we will focus on proving trigonometric equations or doing problem solving involving trigonometric functions. Alright, that's all for today.